Good morning to all. So here in this video, we are going to see about a database management system subject. In the first two units, we discussed about the basics of database management system, and the second unit we are discussed about database design, and the third unit we'll go with the data storage and the query processing. So out of that, we'll go with only the RAID in this video. So RAID is nothing but it is a redundant array of independent disk. So multiple secondary disks are connected together to increase the performance, data redundancy, or both. So here is the very simple. I just go with a very simple example. When you are going for suppose we are going to conduct any program for students. Suppose we need to find only one particular student from a particular department. It can be easily identified with the student with respect to of department. Suppose you are going to find the entire student in the one auditorium. It is very difficult. So like that. So here we have, instead of storing all data in a one disk, we are using some secondary disk. So by maintaining a secondary disk, it is possible to increase the performance. So like when you just compare with the example what I already told of the student finding a student in a classroom. So suppose the students, suppose we just take a second year IT, I need to find one student from a second year IT. It is very possible. So we can quickly find the student, and we may get some information from the particular student. Suppose the student in the our auditorium. So it is very difficult to find, and we'll get so for that we need to find one particular student from the department of IT, and through the student we need to find other students. So it takes some time. So it reduces the performance. So by using a secondary disk concepts, we may increase the performance. So what is the purpose, what is the need for implementing a RAID concept? To increase the performance, increase the reliability. It provides a greater throughput, and data are restored. So instead of saving one data in a one particular disk, it can be stored in multiple or distributed disks. So through that we can achieve data tolerance. So here this is the first level of RAID. So here we'll have you can see A, B, C, D, E, F. So these are all 6 different disks are connected in a stripped array. So the stripped array is nothing but it is independent of independent arrangement of disk with other disk. Okay, A is independent array, A is independent disk, and B is independent disk, and C is independent disk, D is independent disk, and like that we'll arrange a disk in the stripped array format. Okay, so here we are not maintaining any data redundancy. So all the disks are arranged in a one disk. So this is the arrangement of level 0. So data is broken down. So initially, how we are going to store a data in a disk? So we have a huge number of data. So those data are broken down into blocks, and these blocks are stored across all the disks. So here the term is very important, the stripped array of disk. So these arrays are connected independently with other array, so that there is no duplication of data in this level. So once a block is lost, then there is no way recover it. What is that? It gives a meaning that when we are storing a data block in a one disk, if there is any loss in the particular disk, we can't retrieve those data blocks. So there is a biggest problem with the RAID level 0. So it provides a good performance. Why? Because if suppose we need to we are having a data in a one data block, so that we'll get some information very quickly than compared to duplication. And level 1, so here it is follows a mirroring technique. Why? Because in this diagram we'll have A, B, and as well as AB. So it uses mirroring techniques. All data in the drive is duplicated to another drive. So the disk data are stored in one disk, so the same data block is available in another disk. So it provides 100% redundancy in the case of failure. So advantage is fault tolerance. So fault tolerance is nothing but if there is any loss in one disk, we don't bother about that. Why? Because another disk taking care of providing a data to the particular process. So that it is a biggest advantage of level 1. So next level 2, again it uses a mirroring technique. Along with the mirroring techniques, it is going to use error correcting codes bit corresponding to the particular bit. So what is the purpose of error correcting codes? Whether we are sending a correct code or correct data, sorry, the receiver is receiving a correct data from a center. So again, the same definition, use of mirroring as well as stores error correcting codes for its data stripped on different disks. So each data bit in a word is recorded on a separate disk, and the ECC codes of the data words are stored on a different set disk. So due to its complexity, so that level 2 is not available in a commercial. So level 3, so along with the level 2, level 1, along with the level 1, why? Because it uses mirroring techniques. Along with that level 1, it is also used parity. So parity is going to find whether it receives a correct data. So we'll have a definition for parity. Parity is a technique that checks whether the data has been lost or written over when it is moved from one place in storage to another place. So suppose we are going to share data from one storage to another storage. If there is we need to find if there is any lost in the data. So that can be possible with the help of parity. So in the case of disk failure, the parity disk is accessed and the data is reconstructed from the remaining devices. So suppose if there is any data loss in the disk. So just see this diagram. If there is any loss in the data in a disk, so these data are collected or reconstructed from those parity bit. Once the disk failed is replaced, the missing data can be restored on the new disk. So here level 4. So what is the difference between level 3? The only thing is the how we are going to divide the data, whether we are going to divide the data into byte or divide the data into block. Okay, so here we are going to divide the data into block 1. So remaining all are same. It consists of block level stripping with the parity disk. And next level 5. So level 5 will have, so in a level 4 we'll have a separate parity disk in an arrangement, but in the level 5 we are not using any separate parity. So instead of separate disk, so it is going to store in a same disk place. So writes a whole data blocks onto a different disk, but the parity bits generated for the data block strip or distributed here, we are going to store the parity bits in a distributed way in a particular different distributed dedicated disk. And level 6, so in this level 6 we are going to use both level 3 and level 4. Why? What is the meaning of level 3 and level? So it is going to use both technique like error correcting codes and parity character. So what is the biggest advantage of we can two parities provide additional fault tolerance when there is any loss in that data, so it can be easily retrieved from parity bits. So this level requires at least 4 disk drives to implement RAID. So we'll have RAID levels from 0 to 6. And how we are going, and next the last one is to the last one slide is representing that how we are going to select choose a RAID for particular process. The performance requirement in terms of number of input operations, so how many input and how many outputs are used for a particular operations, those are all taken care by using of this consideration. And performance when disk has failed, suppose if there is any loss in the disk fail, so at the time we can based on that failure scenario, you can choose a particular level and performance during a rebuild. So these are all the things are related with RAID. Okay, thank you.